I guess I should share my screen. Can you guys see the screen?
Yep.
Yes.
Right. Keep it there. All right, so this is an AMA for testing and debugging. So in this AMA, we'll specifically talk about GDB and catch testing. So we'll start with catch testing. We'll talk about what it is and why do we need it. So catch is the unit testing framework for C++. If you have used if you have done unit testing in Java using JUnit, it is very similar to that. So it allows you to test each unit or individual function as opposed to just the whole program. It makes debugging much easier because it allows you to just run part of a program and then make sure just catch any bug as early as possible. Catch has a set of macros that can make testing much easier. We'll go over some of the common macros later in the slides. Catch can also divide the test cases into sections, and then we can run the different section in isolation. Overall, it is pretty easy and straightforward to get started. We'll give you some example of a catch test case, and then we'll also show you how to write a simple one. So here are some of the important catch macros. I think there are only 4 you guys really have to know. So the first one is require. It is similar to assert in Python if you guys have ever used that. So it takes in an expression, evaluates it to a Boolean, and then if the expression evaluates false, it will just abort and fail the test case. So for example, if you know the expected output of a function, you can use require to check your function output against the solution output, and then require them to be the same. So the next one is the test case. So as the name suggests, it defines a test case with the test name specified in the first argument, and then you can provide any additional tags if you want. Sorry, is someone?
Oh, that's just me just informing people to ask questions in the chat because there are a few new people who joined. You keep going.
Oh, sorry. Is there a way for me to see the chat, or okay, I'll let you monitor it then.
Okay, I'll monitor it. Don't worry about it.
Yeah, thank you. Okay, so the next one is section. So section is a subset of tests, and it is nested inside a test case. So normally it's for organization of the test case. You can divide a test case into multiple sections where each section can test a specific feature or functionality. So the last one is info. So what it does is that it logs a message in test scope. So it is equivalent to a print statement. I always just add a bunch of info in my test case to make sure which steps it has reached. So if you want to get any additional information of the test case, you can use info. So here is an example catch test. So you can see that we have a bunch of the macro we mentioned earlier. So test case on line 4, it defines a test case to test the size and resize method for vectors. So in the test case, we just first create a vector of 5 integer, and then we have 2 assertions requiring that the size of the vector to be equal to 5, and then the capacity of the vector to be greater than or equal to 5. And then after that, we have a section to specifically test the resize method of vector. So inside a section, we resize the vector to 10, and then we have 2 additional requirements for the size and the capacity. And here we'll cover some of the useful way to run catch. So by default, if you don't pass in any arguments or flags, catch will run the entire test suite. But you can also just run a single test case by specifying the name of a test. So that's the second one. And if you want to see a list of all the tests available, you can use the -l flag. That will just list all the tests, all the test cases in the test file. And you can also use the -s flag to display the output of tests, because by default, successful test output is not shown. So you have to use this flag if you want to see the output for any tests that have successfully run. The last one you can redirect all the output of a test case to a file instead of just printing them out in the terminal. So to do that, use the -o and then specify the file name, and that will send all the output to a file. Yeah, so that was a very quick overview of cache testing. Now let's talk about GDB. So GDB is, which stands for the GNU Project Debugger. It is a very popular debugger for Unix system to debug C and C++ programs. It allows you to see like what is going on inside a program when it executes. Like at first it may seem like a bit intimidating with like all the complicated output, but actually it is very helpful to debug because it gives you like more control over the program execution compared to Valorant. So with Valorant, when you run it, you have to run the entire program until it's finished or until it runs into a bug and just crashes. But with GDB, you can stop like the execution of the program at any point by using breakpoint. And then like once the program has stopped, you can examine the state of the program, like by printing out any variables or like anything in the memory, like on a stack, on a heap, to make sure your function is doing what it's supposed to do. And you can also step through the program like one line at a time and just execute it line by line. You can use this in combination with the printing to like get more information in your program to make sure it is doing like what it's supposed to do. So we will show you a list of some of the basic commands that people normally use for GDB. So to launch your program with GDB, we'll just do GDB and then pass in like the name of the program or executable. Then to run the program, we just do run, or I think the abbreviation is R if you want to run it. And then so the first two command is equivalent to the third one, where you can just start launch GDB with the argument. And then you can like set breakpoint by using break, and then you can specify the file and then which line number to set a breakpoint. I think you can also just like set a breakpoint like at the beginning of the function by like just putting down the function name. So for example, if you do like break main, that will set a breakpoint at the beginning of the main function. And then you can remove the breakpoint by using clear the command, and then list is for showing like where the program has stopped, and then just like a few lines like before and after it. And then you can, so as we mentioned earlier, you can like step through the program and then just execute line by line. So both next and step does that. But like the difference is that next does not go into any function, while step will take you into a function. So if you want to, and then if you want to step out of function, you do finish, and then continue list, you continue the rest of the execution of the program. And to like get some more information for the program, you can use like info and print. So info breakpoints will show you the list of all the breakpoint that has been set. And then info args will show you the arguments in the current function. Info locals will show you all the local variables in the current function. And then you can also like print out any variable, or like you can print out the value or the expression of a variable. And then you can also do like a backtrace to show the call stack of the program. So that's like some of the common commands. So for a list of more detailed commands, just you feel free to check out this link. Yeah. So that was, I know like the AMA is pretty short. So we will now do a demo, but before that, does anyone have any questions so far? Let me check the chat. Yeah, feel free to unmute and then just speak up, or you can also just type the question in the chat. I guess that means we don't have any questions so far, so I guess we should do the demo. Does GDB recompile when adding breakpoint? I don't think so. Correct me if I'm wrong, but I don't think so. I guess that's all the questions for it. Um, right, I guess I'll just start a demo. Um, so the code of the demo is taken from one of the POTD. So to give a really quick summary, we have like a really simple linked list, one that's different from the MP, but it would be helpful. Um, so so we have like implement this function called list union, which takes in two linked lists and try to take the union of the linked list while keeping it sorted. So here we have like two example output for the linked list. So we'll show you a test cases for the second example. So the first list will be 0, 2 to 2, and then the second list will be 0, 0, 0, 4. So here is test case. So here we define a test case called test union. So first we will like create two linked lists. So the first one, so which two linked lists, L1 and L2, and then we will try to call our list union function, and then store whatever return in the answer variable. And then since we know like the expected output for the function, so we will make a third linked list for the solution, which is 0 to 4. And here you can see that we are using the info macros to print out the solution and the answer. So list to string is a helper function to print a linked list. When you write your test, feel free to like include like add any helper function that may be helpful. So and then lastly, we just require the answer linked list to be equal to the solution. The is equal is also like a helper function that go through to a linked list to make sure like they store the same data. So you can try running the test. Going to place. You guys can see the terminal well, right? Should I zoom in a little bit?
I think it's good.
Okay, cool. All right, let's make the test. I think I have to do the module load. All right, so it compiles. So let's run test. Yeah, so everything works. So the test cases pass. So right now we only have one test case, but so if you have multiple test cases, you can like specify the name and then just run that one single test case. So we can just like just run like the test union test case. But in this case, we only have one test, so it's the same. So you can also list all of the test case available by using the dash L. So here it shows that we only have one test case, test union. I think another things you can do is that so if the output is like huge and then it's hard to like read through all of them in the command line, you can also direct the output by using the dash O flag to a file. So let's do it to like a output.txt file. So if you do that, it will create a file called output.txt. So let me yeah, wait, actually, right, since all the test case is successful, it's not outputting anything by the info, so we can use the flag dash s to show any output if you're curious. So we can see that the info output is shown here in the file. So the solution and the answer matches up. Yeah, so I think that was all the commands for the catch. And I think now we can try out the GDB part. So actually, let's try to introduce a bug in our code and then use GDB to help us figure out. So let me try to do something to our list union function. So here, let me just comment out this line. Like we know it will give us an infinite loop because the condition, the stopping condition for the while loop uses L1, but then if we comment out of line 49, we never update L1. So we'll just get stuck in this while loop. So let me like yeah, so if you run tests, you can see that it gets stuck. And then let's try that with the GDB. So if you do gdb./test, we will load the test with GDB. You can see there's like a bunch of output before, and then it brings you in the GDB command prompt. So let's set a breakpoint at the beginning of the list union function. So we can use break or the abbreviation B, and then let's do list union. And then it shows that we have set a breakpoint in the file node.cpp at line 45. You can also just like see all the breakpoint you have set so far using info breakpoint. Here you can see that we have only one breakpoint. So we can now run the program and then it should stop at the breakpoint. So here we stop at node.cpp line 45, which is the beginning of the list union function. So we can use list to show like the code before and after. And then we can step through it using next or n to see the next line. So if you do it a bunch of times, you can see that it just gets stuck in this loop because we are always just going through the same thing. So let's try to print out what is happening with L1. So if you do print L1, you can see that this is the whatever stored in L1. And then let's go through the next iteration of the while loop. And then when you print L1 again, it's the same thing. So hopefully that gives you some hint on where the bug might be, because if you check that L1's the same and then it never got changed, so that may be the reason why you got stuck in an infinite loop. So that, I think that is most of the command for, yeah, I think so. Some of the other command you can use is like info, I think args, that shows you like the argument of the current function, which is list union. Oh, actually, I want to show like the step. So let's go here. So the difference between next and step is that next will just like continue to the next line without stepping into any function. But then let's say you want to go into insert sorted and then see if there's anything wrong with it, you use ask, and that will take you inside the insert sorted function. You can see that it's like in the node.cpp file, line 6, that's the beginning of the insert sorted function. You can continue print things out, check if everything looks all right, and then if you're done with the function, you can step out using finish, and then that would take you from the function like back to whatever function that calls it, which is list union. So we can do continue to continue the rest of the program. And then since we have a infinite loop, it'll just get stuck. So I think I have covered most of the command. Let me know if I missed any. Yeah, so that was just a really quick demo. I know this AMA is pretty short. Hopefully it gives you some like reference on how to do debugging and testing for the NP and any like future assignment. Does anyone, so now it's time for questions. Does anyone have any other question?